everyone. My name is Kumar and I welcome you all on my presentation, and my topic is IP addressing and subnetting. And this is the index we will discuss in future in next slide. First, IP addressing. What is IP addressing? Every node in computer network is uniquely identified using IP address. You saw in the picture two node is connected with the switch and both have unique IP address 192.168.1.34, and computer we have IP address 192.168.1.35, and it can be changed based on the location of the device. And there are two type of IP address, that is IPv4 and IPv6 addressing. IPv4 consists of 32 bits and it has 4 octets. Each octet is in size of 8 bits, and its range from 0 to 255, and the total number of IP address in IPv4 is 2 to the power 32 bit IP. And in IPv6 it consists of 128 bits, and it has 8 groups of 4 hexadecimal digits. You can see in this example, and each group of size 16 bits inside, and total number of IP addresses 2 to the power 128. Now we will discuss about classful addressing. I tried to clear all the concept using this circle of the classful addressing. The total number of using IPv4 address, the total number of IPv4 address, half of the address is assigned to class A, means 50%, and to divide it into two parts, there is 1 bit is needed. So here is the starting bits of class A 0 and 1. So the starting in the first address, if the starting value is 1, we can say that it is the address of class A, and it has 2 to the 1 bit is fixed. That's why it has 2 to the power 31 IP. And in the remaining 50%, half of the 25% is going to class B, and to divide it into the remaining two parts, we need one more extra bit. That's why we take here 0 and here 1. So the starting, if the in the first octet, if the starting multi-decimal is 10, we can say that it is the class B address, and in the remaining parts, we can divide it into two parts. That's why we need more extra bit 0 and here 1. So to identify class C, in first octet, if the value decimal is start with 110, we can say that it is of class C, and class D and class C is equally partition into two parts, 6.2 parts of remaining percentage, 6.25%, 6.25%, and the IP is 2 to the power 38 because 4 bits is fixed. That's what. Oh, back. And in decimal range, it is range from 1 to 126 of class A. In class B, in decimal range, it is range from 128 to 191. And in class C, it is range from 192 to 223. In class D, it is range from 224 to 239. And in class D, it is range from 240 to 255. And the subnet mask for class A is 255.0.0.0 because in class A, the network ID is of 8 bits and the host ID is of 24 bits. That's why the subnet mask is 255.0.0.0. In class B, the network ID is of 16 bits and the host ID is of 16 bits. That's why we take subnet mask 255.255.0.0. In class C, the network ID is of 24 bits and the host ID is of the 8 bits. That's why we take subnet mask 255.255.255. Class B is reserved for multicasting and class E is reserved for future reference. Next question. I can already discuss all the things shown in this table. Class A network ID is of 8 bits, host ID is 24 bits, number of networks. Because what bit is fixed in class A, that's why number of networks is 2 to the power 7 minus 2, and number of hosts is 2 to the power 24 minus 2. In class B, network ID 16 bits, host ID 16 bits, number of networks is 2 bits is fixed, that's why 2 to the power 14, and the number of hosts is 2 to the power 16 minus 2. In class C, 24 bits is of network ID, 8 bits of host ID and 3 bits is fixed to identify class C networks. That's why number of network is 2 to the power 21 and number of hosts is 2 to the power 8 minus 2. Class C is reserved for, I already said that use for multicasting address, and class C is reserved for future reference, and this is the range of the special IP address I can discuss. Now we will discuss about classless addressing. In classless addressing, there is no use of classes and blocks. As per the demand from, we provide the IP. As this example shown, there is no specific network ID or host ID, 32 bits it is inside. Whenever demand come, we can partition this into network ID and host ID. And notation is, in the example, by slash we can identify its classless address. That's because in the example it is slash 21, which means in number of ones is 28. Then we can identify network ID. In this network ID, the subnet ID is also hidden, and the remaining parts is host ID. So the network ID has network ID plus subnet ID. So we can identify the number of subnet here from this. Now we will discuss the topic subnetting. Subnetting is dividing a huge network into a smaller one, means subnet. You can see in this circle there is a huge network. We can subnet it into 4 number of subnets, and it is of 2 types. One is fixed length subnetting and another is variable length subnetting. We will discuss in further slides. Fixed length subnetting. In fixed length subnetting, each subnet got equal number of addresses. We can discuss it through the example. We can say that is class C address because the starting octets is from 200 and the range of class C address is 191 to 223. That's why it is of class C address. So in example, we have to divide it into 2 subnets. That's why we divide it into 2 subnets, subnet A and subnet B. So we can already discuss that the subnet mask of class C address is 255.255.255. By adding this, we can get results as 200.1.0. So that is network ID. So we can divide the host ID. That's why to dividing into 2 parts, there need 1 bits, 0 and 1. That's why 0 is fixed here in class A and 1 is there. And remaining 7 bits for subnet ID we can put all 0, and for broadcast ID we take all 1. In the B parts we do the same thing. So the starting address is always the subnet ID of the class. There I will discuss, and the broadcast ID is the last address. And in range it is range from 0 to 127, but allocated range is from 1 to 126. And in the same process is discussed in class B. The subnet ID is 128 of class B, and the broadcast ID is 200.1.2.255. But the allocated range is from 129 to 254. Next slide.
8 minutes. तो यहाँ पे total what's the range of this network? This subnet का इस network का range क्या होगा?
इसका क्लास A या क्लास B?
नहीं, total range कितना होता है? कहाँ से कहाँ तक होगा? Exact range.
0 से 255.
तो आपने 2 bits यहाँ निकाल दिया, 2 bits यहाँ निकाल दिया, तो 4 bits आपका क्या हो जाएगा? रिजर्व हो गया.
मैम 0 रिजर्व किया क्लास A के लिए, क्लास B के लिए.
जैसे आपने पहले भी क्या कि क्लास A में 2 अपन -2 करते हैं, ठीक है? जो स्टार्टिंग एड्रेस और लास्टिंग एड्रेस दो बैक एड्रेस दो क्लास B अपन निकाल दो. यहाँ पे टोटल कितने एड्रेस को माइनस करोगे? रेंज आपका 4 हो जाए, -4 करोगे ना, जो जितने भी रेंज होंगे उसमें -4 करोगे. वही मैं पूछ रही हूँ. चलो नेक्स्ट.
Now we will discuss about variable length subnetting. Variable length subnetting allows to create subnet with different subnet masks to utilize better utilization of IP address. We will discuss through another example, that is 200.10.20, and this all is of class 2 addressing. So it is another it is of class C address. So In variable length subnetting, we have to divide into three parts. For dividing into two parts, we use 1 bit extra in host ID. That's why here we take 0 and there we take 1. So the remaining bits for subnet ID we put all 0, and for broadcast ID we put all 1. And for partitioning class B and class C, we need one more bit to divide it. That's why we take 0 and here 1. And remaining bits is 0 and remaining bits is 1. And in class C, remaining bits is 0, remaining bits is 1. And it is range from 0 to 127. First ID is subnet ID and last ID is broadcast ID. Same process done in class B and same also in class C. Next. Now we will discuss subnetting is classless addressing. So in classless addressing we will play with subnet mask. So here in example, /28 means 28 ones in subnet masking. If we ending this IP address and subnet mask, we get network ID. So by ending the subnet mask and IP address, we get same address because all the ones in subnet mask till the third octet. In fourth octet, there are number of 4 ones, so we can convert 5 to 4 ones. We get 0. That's why that in network portion 4 parts is 0 and host ID is of 4 bits. So we can divide into 2 parts. So we take 4 zeros in subnet A and subnet B, and 0 is fixed and 1 is fixed for dividing into 2 parts, and remaining 3 bits is 0 from 1, and in class B remaining 3 bits is from 0 to 1. So because of 1 bit we can fix, that's why here subnet mask increased to 28 to 29, and it is ranging from 201.10.20.0 to 201.10.20 to 7. And that's in class B, subnet B, it is from 201.10.20.8 to 201.10.20.15. Next. And this is complete. If network ID is valid and host ID also 0, we can say that it is the network ID of entire network. And if network ID is valid and in host ID all ones, then we can say it is of the direct broadcast address. In network ID all ones and in host ID all ones, we can say this is of the limited broadcast address. And in network ID, if all ones and host IDs all 0, it is denoted default subnet mask.
Yes, right. Yes,